Let me restate all the 4 derivatives that I mentioned last class. Okay, so these were the following. If f of x is equal to ln x, then we said if f of x is equal to the log in base a of x, then if f of x is e to the x, and then if f of x is a to the power of x. Okay, so let's write down the derivative for each one. Okay, so f prime of x, f prime of x, prime of x, and f prime of x. Okay, so the derivative of ln x, this we showed already, it's 1 over x, right? So this was already proven. This is done. And log in base a of x, so this we didn't prove yet, but I wrote down that it was equal to 1 over x ln a. Then e to the x, the derivative was e to the x, and a to the x, derivative was a to the x times ln a. Okay, so we need at this point to prove these 3, and then we're going to do a few examples on how to apply everything with the chain rule, product rule, and everything mixed together now. Okay, so let's prove. Let's prove. So the first proof that I want to do is this one here, is that if f of x is equal to the log in base a of x, then f prime of x is 1 over x times ln of a. So this is what I want to prove. Okay, which is this one here. Okay, so the first proof that we did that ln of x, the derivative is 1 over x, was pretty complicated because we used the definition. But this is going to be much easier now, because what I'm going to do is I'm going to go like this. F of x is log in base a of x, which is log in base a of x. If you use the properties of logs, it's ln x over ln a. Okay, the 4th property that I showed you last class of logs is that if you divide 2 logs that have the same base, so in this case the base is e in both cases, then the a becomes the base. So these 2 things are the same. You good with this?
Yes.
Okay, so now if I want to find f prime, well, I just need to derive this, same thing. So it's ln x over ln a prime. Right, that's what it is. And that's pretty simple because ln of a, this is a constant, right? It doesn't depend, the function doesn't depend on a, it just depends on x. X is my variable. So I could treat ln of a as a constant, and so I could pull it out of the derivative. So it's 1 over ln a times whatever's remain inside ln x prime. Okay? And then the derivative of ln x is just 1 over x, like we proved last class. So it's going to be 1 over x times ln a, and that's it, done. Much simpler once we know that the derivative of ln x is 1 over x. Are there any questions? Okay, so let me just go back here for my satisfaction. I'm going to put in a check here because this is proven now. Okay, if you have no more questions, no questions on this, I can move on. And let's prove the second one, the third one actually, which is that If f of x is e to the x, then the derivative stays e to the x. Okay, let's go for it.
Wait, sir.
Yeah.
Can you quickly explain why log base a of x is equal to ln x over ln a?
Why this true?
Yeah.
Okay, because we, when I wrote down the properties of logs, okay, just write it here. Okay, we said that one of the properties is that if you have log in base b of x divided by log in base b of y, this is equal to log in base y of x. This was the fourth rule for logs. You remember the change of base? I don't know if you remember this. You don't remember it, right?
Wait, so how did that become ln?
Well, I could have put any base here. I could have said log in base 2 of x divided by log in base 2 of 8. It would work as well, as long as the bases are the same.
Oh, okay, so you just put
I choose ln because I know the derivative of ln. We proved it already.
Oh, okay.
That's why. Okay?
Okay.
Any other questions? All right. Let's prove the third property, the third derivative now. So f of x so if f of x is equal to e power x, then f prime of x stays e power x. Okay, so let's prove this. So ln, I'm gonna state something for you guys. Ln of e power x, what is that equal to?
To the x.
What is it? What? I didn't hear, sorry.
It's x. No?
It's x, very good. Okay, ln of e to the x is xy because the base here is e, so e power x gives me e power x, yeah. So e power what gives me e to the x? Well, x. Okay?
I don't understand that. Sorry.
Sorry?
I don't understand that, like, e power x gives x. Oh, I think I do actually. Never mind.
You think? I'm not happy with that thing. You have to be sure. Are you
I'm not
sure?
sure. No.
You're not sure, you think?
Yeah, I'm not sure.
Okay, so here, quickly, ln of e power x. So as you know, when you have the log and you have something power something, you could bring the exponent in front, right? This we know?
Yeah.
Okay, so this is equal to x times ln of e. And ln of e is what? This is 1, right? E power what gives me e? 1.
Okay, thank you.
Okay. Any other questions? Ask all your questions, please. Okay. Okay, so at this point, we established that ln of e to the x is equal to x. So what I'm going to do now, since they're equal, so if I do the derivative of both sides, it's still going to be equal. Okay, two functions are the same, so if I derive them, their derivatives are the same. So that's what I'm going to do. I'm going to do the derivative of both sides. So ln of e to the x prime is equal to x prime. Okay, just do derivative of each side. Okay, so what's the derivative of ln of e to the x? How do you do this?
Don't you have to do a derivative of ln times ex and then times the derivative of ex?
I'm not sure I understand what you said. So
Like
the
the
derivative
chain
of,
rule?
good, yeah, chain rule is good. So what do we do?
So you do the derivative of ln.
Ln. What is the derivative of ln?
It's 1 over x, I think.
No, it's 1 over what's inside.
Yeah, 1 over ex.
1 over ex.
And then
Times-
times the derivative of ex,
Very
which
good.
is
That's which is I don't know, which is what I'm looking for,
oh yeah.
right? Good. Equals the derivative of x is
1.
1. Perfect. Good. So now I'm going to isolate e to the x prime. So what do I get? E to the x prime, so you send the e to the x up here, you get just e to the x, and I'm done. Looks easy when I do it, but that's all there is. Okay, so how did I get from this step to the last step? I just basically multiplied both sides by e to the x. Okay, so I get e to the x prime is e to the x. That's what I want to show. E to the x prime is e to the x. Any questions? Okay.
Sir,
Yeah.
how'd you get to the from the first derivative to the second step?
From here to here?
Yeah, but on the other side.
On the left?
Yeah.
Okay, so what I did here, so this is a chain rule. It's ln of a function. Okay, ln of a function. So it's 1, when you derive ln, it's 1 over what's inside. So 1 over e to the x, right? The derivative of
always,
ln. What?
It's always 1 over whatever's inside.
Always.
Okay. Thank you.
And that's it.
Okay,
Okay.
that makes sense. All right, thank you.
No problem. So let me just go back here and put a check here because this is proven now. Done. Okay, last one. That if f of x is equal to a to the x, then f prime will be a to the x times 1n. Okay, so again, I'm going to write something that I know. So ln of a to the x is equal to what? What is that equal to? I could bring the x in front, right?
X.
X times ln of a. Is that okay? And now I'm going to derive both sides. So ln of a to the x, x ln a. So if I prime this side and I prime this side, I get the same thing. So what's the derivative of ln of a to the x?
1 over ax.
1 over a to the x times what?
ax prime.
A to the x prime. Okay, don't say ax, because if you say ax, I understand a times x. Okay, so say a to the x. So I know that the x is in the exponent. And here, ln a is a constant again. Okay, it doesn't depend on x. So I treat it as a constant, so I could pull it out of the derivative. So ln of a times the derivative of x, which is 1. Is this okay? I guess so. And so I could isolate a to the
Sorry,
x.
can you explain that again?
The last step,
what you said before about ln.
So this is ln A, I could pull that out of the derivative, times the derivative of x. I just pulled out the ln A outside of the derivative.
Okay, thank you.
And this is 1. Okay, so this we know, it's 1. Okay, so here we have a to the x prime is equal, so I send the a to the x on the right, so a to the x times 1a, and that's what we wanted to prove, finished. Do you have any questions? Okay, so let's go here. And very important, we put a check here because it's done. Okay, so at this point, let's do some examples on applying all these rules. Okay, so we'll do a few. And then once you get the hang of it, we'll go to implicit differentiation. Okay, so example, find f prime of x. Okay, so first one. Let's say f of x is equal to 6 to the power of tangent x. That's 1. 2. F of x is log in base 3 of, let's say, cosecant to the power of 4 of x. And then 3. Let's say f of x is equal to e to the power of sine x plus 1 over, let's say, sine x. Okay, do you want to try it or you want me to do them?
You do it.
Okay, so let's do it. Okay, so f prime of x here. So we know the derivative of a number power a function is the same thing, it stays. So 6, or even 6 to the power of 10x times ln of 6. This we know, we just showed. A power anything stays times the ln of the base times the exponent times the derivative. Okay, and I just have to evaluate the derivative of tangent and I'm done. So 6 to the power of 10x times ln 6 times the derivative of tangent, which I hope you know by now that it's secant squared x. Okay. Number 2. So f prime, so we have log in base 3. So log in base 3, we know it's 1 over what's inside, right? 1 over cosecant 4x times ln of 3 times the derivative of the inside. Any questions? Okay, so I just need to derive this, and this we've done. We've done this before. So it's equal to, this stays 1 over cosecant 4x times ln 3 times the derivative of cosecant power 4 is 4 times cosecant 3 times the derivative of cosecant. Okay, no questions? I'm going to continue here because I'm running out of space. So it's 1 over cosecant 4x times ln 3 times 4 times cosecant cube x times the derivative of cosecant is negative cosecant times cotangent. Okay, and I'm done. I'm done deriving. Here, in this case, I'm going to simplify because there's a lot of things that cancel out. And that is cosecant cubed times cosecant is cosecant 4 with this cosecant 4 cancels. And so my answer is negative 4 cotangent of x over 1, 3. Okay, any questions?
Wait, sir, can you just repeat what cancels out?
What canceled out is cosecant cubed times cosecant is cosecant 4 divided by cosecant 4, they cancel. We're good? Okay, last one. So here, of course, we have a quotient rule. Okay, there's a division, so quotient rule. So the derivative of the top times the bottom minus the top times the derivative of the bottom, and all this over the bottom squared. Okay, and now I'm going to do the derivative of this. So derivative of e to the sine stays e to the sine times the derivative of sine. Okay, times sine x minus e to the sine x plus 1 times the derivative of sine x, which is cos x. All this over the sine squared of x. And that's it. I just have one derivative to evaluate and I'm done. E to the sine x times cos x times sine x minus e to the sine x plus 1 times cos x divided by sine x squared. And this is my answer. Okay, so it's pretty much just like before, except that now you have more functions to deal with. You have the ln and the tau.
Sir, on the test, would you like make us like factor out the cosine and all that?
I might ask you to simplify, but yeah, I might ask you to simplify. So if it's the case, I'll ask you the question, simplify your answer. Okay, so for now, I'm just focusing on derivatives because what's important for me is for you to get to this point, to make sure you know how to find the derivatives. After that, the simplifications, of course, it's important, but This is just high school stuff, okay? But we'll do it eventually.
Yeah, thank you.
Okay, any questions? That's it. That's all there is with logarithms and exponential functions to derive. Okay, so I mixed everything together here, quotient rule, exponential, trig, everything mixed together. Okay, so we can start the last part now of derivatives, which is implicit differentiation. All right, so implicit differentiation. Okay. So let me explain to you what implicit differentiation means. Okay, just a second, let's throw this away. Okay. So let's say I'm giving you y equals to 7x5 plus 2x3 plus x minus 1. Okay, here we say that y is expressed explicitly. This is what we've been doing so far. Okay, y, you see it right away, it's isolated, and you know what y is. But if you have something like this, x, y, 5 minus 2y2 plus 3x equals -5, let's say. Well, now, you know, the y is not isolated. There is a relation, there is a set of points that work here, okay? But I cannot express y explicitly. I can't express y. So in other words, I cannot isolate y here. Okay? I don't know how to isolate here. Okay? So in this case, we said y is expressed so implicitly. Okay, so the difference between explicit and implicit, very important. So we're going to deal now with this kind of equations, okay, implicit equations. Okay, so in every case, we treat y as a function of x. Okay, in other words, y is actually equal to, if you want, y of x. Okay, it's a function of x. Y depends on x. Okay, any questions? Okay, let's go straight to evaluating the derivatives in such situations. Okay, and see how we deal. You basically know how to do it, but you're going to see it better now. So for example, let's say, okay, so I'm asking you to find y prime, okay? Or if you want dy dx, okay, same thing, y prime, okay? Or if you want dy dx, means the same thing. Okay, we're going to use y prime because it's less heavy on the notation. Okay, so 1. Let's say x4 plus y5 equals 5x plus 2. Okay, so that's a very easy one. Okay, I'm asking you to find y prime. Okay, so what I could do, okay, of course, is I could just isolate the y here. Okay, I could send x4 to the right, and then do the fifth root, and then do the derivative using the chain rule. Okay, that's gonna work. Okay, because here I could isolate the y, but here on top, right here, right, as you see here, I cannot isolate the y. So if we have a situation like this, we're stuck. So let's find y prime here, just like if we couldn't isolate y. Okay. So I'm going to derive both sides. So what's the derivative of x4?
4x3.
Very good. 4x3 plus, what is the derivative of 5y?
5/4.
5y4, perfect. But 1 second. Y we said was a function, right? Y is equal to y of x. So if I'm deriving with respect to x, well, I have to do the derivative of the inside as well. Okay, it's a chain rule. So I have to multiply this by the derivative of the inside. Are you with me? That's the tricky part. Okay, equals to, on the right side, I just have 5, right? Because the derivative of 2 is 0. Questions? Okay, so I'm just going to isolate y prime now. So 5x4y prime equals to 5 minus 4x cubed. And so y prime is 5 minus 4x cubed over 5y4. And this is my derivative. Any questions? Okay, that's a very easy one. Let's do another one, if you have no questions.
Do you not go on further to
what?
solve for only x? Like you leave the
No.
y in the equation?
No, because chances are you won't be able to. Here you can, but if you could isolate y here, then you could have isolated y here as well directly. Okay, so I'm assuming that you can't. Okay,
Okay, so this is the final answer.
that's your final answer. This gives
okay.
this gives you the derivative, right? It gives you the slope of the tangent at any point xy in the curve. Okay, so you might have a curve like this, which is not necessarily a function, but you might have a curve like this, let's say, and you have a certain point here, xy, and what this gives me, it gives me the slope of the tangent here, depending on xy. Do you understand?
Oh, okay. Yeah, I think I understand. All right.
It's the same thing as the derivative of the normal derivative.
I'm sorry, didn't hear. Sorry.
But the normal derivative, the equation of the tangent line, it still gives you any point. It gives you the slope of any point. So what's the difference?
Because in this case, chances are it won't be a function, and so if, for example, the x is here, then there's going to be 1, 2, 3, 4 points. So 4 different slopes. You see?
Okay.
So now if you tell me at point xy, then I know that I'm dealing with this point only.
Okay.
Okay? Okay, let's do another one. Number 2. So still easy. I'm not going to complicate it too much for now. So 5y3 minus 3x2 plus y equals to 1. So I'm going to derive the left side. So I get what? 15 y2, right? Minus 6x plus the derivative of y, which is y prime equals to 0. Is that okay?
What?
What?
Isn't the first term a chain rule?
Is it the first term what?
A chain rule.
Yeah, so what's missing here?
Y prime.
Okay, thank you. Okay, so I'm missing the y prime here, very good. Okay, you all got this? Okay. So I'm going to send everything to the right now, except, so everything that doesn't have a y prime, I'm going to send to the right. Okay, so I have 15, so I could isolate, I could factor out a y prime here. So y prime times 15 y2 plus 1 is equal to 6x. Do you understand the step? Okay, so the 6x went to the right. And these two terms have a y prime, which I factored out. And now I could isolate y prime. So y prime is 6x over 15 y2 plus 1. Any questions?
So this is like the tangent line, right? Like,
Excuse me?
is this like the derivative, like a tangent line, like a slope of the tangent line? Sorry.
This is the slope of the tangent line at point xy on this relation.
Oh, okay.
Exactly.
Sir, I missed an explanation. Why on the second step is it equal to 0?
Y in the second step is what? What equal to 0?
Well, the term on the left is equal to 0, not 1. Why?
On the left, on the right. This?
Yeah, this one.
Oh, that's on the right, right?
Mm-hmm.
Why is it 0?
Yep.
Because if you derive 1, what do you get?
Oh, I got 0. Okay. So
Okay, so I derive both sides. Okay, let's do, unless you have other questions. Okay. Let's do number 3. Okay, so we're going to do a few until we get the hang of this. So let's say 3y minus 5y4 plus 2x is equal to 2y cubed. So I'm going to derive the both sides. So this becomes 3y prime minus, this is 20y cubed y prime plus 2x prime, but x prime is 1, so just 2 equals, and the derivative here is 6y2 times y prime. Okay, so this is the most important steps, this one. Okay, because it's a step where you actually do the derivative. Okay. So now I'm going to send everything that has a y prime on the left and everything else on the right. Okay, so basically, so 3y prime minus 20y cubed y prime minus 6y2 y prime equals -2. Then I factor out a y prime. 3 minus 20y cubed minus 6y squared equals -2. And so y prime is -2 over this whole expression. 3 minus 20y cubed minus 6y2. Okay, and this is my answer. Okay, any questions before I complicate things a bit?
I have a question.
Yep.
When you did, like, I know, I understand why you do it, like that you make all the y's become y prime as well. Is it because it's a chain rule, or is it because it's a different function in it?
No, it's because it's a chain rule.
Okay.
Okay, because my independent variable is x. Okay, that's what I said at the beginning. Let me just go back. Go back here. Here, I wrote that y, that's very important, y is a function of x. Okay, so if you treated x as a function of y, okay, we could, x as a function of y, we could find x prime, or if you prefer, dx dy. Okay, but I'm treating y as a function of x, so that means that every time you see a y, you have to assume that it's bracket, and inside this bracket is a big function.
Oh, okay, I understand. Thank you.
Any other questions? Okay, so let's complicate things a bit more, okay? x3 plus xy5 minus 2y equals 7. Okay, so let me do this one. Okay, so let's derive the left side now. We have to be very careful. So the derivative of x3 is 3x2 plus, and what do I do here?
Product rule.
Very good. Okay, so very important. There's a multiplication here, and this people tend to forget. But this is a times, so we have to do the product rule. So I'm going to open brackets here and do the product rule. So the derivative of x, which is 1, times y5 plus x times the derivative of y5, which is 5y4 y prime. Okay, so you have to be very careful. A lot of things going on here at once. Okay, there's a product rule, and then y you treat it as a function of x, so you have to do the chain rule here. Okay, which is not obvious because it's sort of hidden. You see a y and just say y. You just say very tempted 5y4, and that's places where people forget it because you're so preoccupied about the product rule that you forget about this chain rule, which is sort of hidden. Okay. Minus, so this will be 2, right? The derivative of 2y is 2, and equals 0. Is that okay?
Don't you need to put a y prime at the end?
Yeah.
Okay.
Okay, perfect. Okay, good. Good. You're starting to know. Is it because I leave too much space that you notice, or you knew it before?
No, because from before when we had 3y, you made it 3y prime. So.
Okay, good. Okay, so be careful. Okay, I'm just making the mistakes. If you're able to identify my mistakes fast, then you're going to develop the reflexes. Okay, let's keep going. So at this point, that's it. The derivative is done. So now let's do algebra and isolate the terms that have a y prime. So I see a y prime here and a y prime there. That's all I see. So let's do it. So 5x y4 y prime, 5x y4 y prime minus 2y prime. These are my two y prime terms, equals, and everything else on the other side. Negative 3x2 minus y5. Okay, so now let's isolate a y prime here. Y prime times 5x y4 minus 2 equals negative 3x2 minus y5 and then I could be done right away. Y prime is negative 3x2 minus y5 over 5x y4 minus 2, and that's my answer. Okay, let's go. Number 5. X4 minus X3 Y2 plus X2Y equals to, let's say, 3 power X. So the derivative of the left is 4x cubed minus, and again, I have a product rule here. Okay, so the derivative of x3, 3x2 times y2 plus x3 times the derivative of y2, which is 2y y prime. Plus, and I have another product rule here. 2xy plus x2y prime. Is that okay? Equals, and on the right side, the derivative of 3 power x, we just proved this today, that stays e3 to 3 to the x times ln of 3. Good? Okay, now let's just do some algebra and isolate all the terms that have y prime, keep them on the left, send everything else to the right. So 4x cubed minus 3x2y2 minus 2x3y y prime plus 2xy plus x2y prime equals 3 to the x ln 3. Okay, so on the left side now I have 2 terms. So y prime times negative 2x cubed y plus x2, so these 2 terms, equals everything else goes on the right. 3 to the x ln 3, so let's go minus 4x cubed plus 3x2y2 minus 2xy. And that's it. I'm going to just divide this by that, and I got my y prime. 3 to the x ln 3 minus 4x cubed plus 3x2y2 minus 2xy over, yeah?
Why is it negative 2x cubed times y prime?
This here?
No, why is it negative?
This negative?
Yeah.
Because if I take out the bracket here, there's a minus in front, so the minus gets distributed here.
Oh, okay, okay. Yeah.
Okay. And that's it, that's my answer. Okay, let's do one last one. Number 6. So let's say e power y minus the sine of xy minus xy3 equals to 3x plus secant x. Okay, so pretty much everything is mixed in this question. Okay, so since we don't have much time left in the class, I will just do it right away. Okay, so at least you will have it in your notes. Okay, so let's do it. So the derivative of e to the y is what? It states e to the y times y prime, right? Don't forget, still chain rule. Minus the derivative of sine is cosine. So cos of xy times the derivative of the inside. Okay, minus, and here I have a product rule. So 1 times y cubed plus x times 3y2y prime equals 3 plus the derivative of secant is secant x tangent x. Okay, so we're not done deriving. We need to derive this now, which is again the product rule. So let's go. E to the y prime minus cos xy times, and this is 1 times y plus xy prime minus, I'm going to get rid of the brackets here, y cubed minus 3xy2y prime equals 3 plus secant x tangent x. Okay, almost done. The derivatives are done. So now let's isolate this term, which has a y prime. Oh, and this term actually. Okay. So let's go. E to the y times y prime, and then I'm going to multiply inside. So minus y cos xy minus xy prime cos xy minus y cubed minus 3xy2y prime equals 3 plus secant x tangent x. Okay, 2 more steps, almost done. So y prime times e to the y minus x cos xy and minus 3x y2 equals 3 plus secant x tangent x plus y cos xy and plus y cubed. And therefore, y prime will be this over that. 3 plus secant x tangent x plus y cos xy plus y cubed over e to the y minus x cos xy minus 3 xy2. And this is my answer.